Hello everyone, welcome back to my YouTube channel. In this video, I want to explain how to solve EJU Mathematics 2019 first session, course 1, number 4, which is the second question from part 2. You can check link on the description box below if you want to watch the solution for the other problem on this paper, or check my EJU playlist for another paper. Okay, in this question, let A be a real number for the two quadratic function in X, which is f of x and g of x. Answer the following question. The range of values of A such that the equation f of x equals to g of x has two different solutions is blah blah blah. So for the first question, we want to find the range of value of A such that f of x is equals to g of x has two different solutions. So first of all, I will equate f of x equals to g of x. Then I will get x squared plus 2ax plus a squared minus a is equals to 4 minus x squared. And then if you move 4 minus x squared to the left hand side, you will obtain 2x squared plus 2ax plus a squared minus a minus 4 is equals to 0. As you can see, we have a quadratic equation here. Then our quadratic equation must has two different solutions. That means for the quadratic equation has two different solutions, the discriminant must be greater than 0. The formula of discriminant is b squared minus 4ac, yeah? This is a and then this is b, the rest is c. That means b squared 2a squared minus 4 times a times c. A squared minus a minus 4 must greater than 0. If we simplify this expression, we will get 4a squared minus 8a squared plus 8a plus 32 greater than 0, and then negative 4a squared plus 8a plus 32 greater than 0. If I divide these inequalities by negative 4, I will get a squared minus 2a minus 8. Don't forget to flip the sign, yeah, because we divide it by negative number. So it becomes less than 0. The solution of these inequalities is the range of value of A, such that this equation has two different solutions. So if I factorize a squared minus 2a minus 8, I will get a minus 4, a plus 2 less than 0. I got two critical values here, which is a equals to 4 and a equals to negative 2. Then I can draw the number line. And then I will put the critical value, which is negative 2 and 4. And then I will check the sign here. As you can see, the coefficient of a squared is positive. Then the sign on the middle region here must be negative. And then the other is positive. Since we want to find the region which is less than 0, so my solution is this one, which is negative 2 less than a less than 4. So for K and L, my answer is K is equals to 2 and then L is equals to 4. This is the first question. And then in the case of 1, the parabolas y equals to f of x. Of course, f of x is a parabola since this is a quadratic equation. And g of x, of course, g of x is also parabola because this is a quadratic equation. Intersect at 2 points. We are to find the range of value of a such that both of the y coordinates of these points of intersection are positive. Now we want to find the range of value of a such that both of the y coordinates of these points mean these 2 points, yeah, of intersection are positive. First, let h of x is equals to f of x minus g of x. Since the solution of the equation f of x is equals to g of x are the x coordinates of the point of intersection of the parabola y equals to f of x and y equals to g of x, the solution of h of x equals to 0 have to be between blah 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 and blah blah blah. So now I will find m and n first. What is m and n? Basically, m and n is the location of the point of intersection of parabola y equals to f and y equals to g. If you see from the equations here, we have g of x, which is 4 minus x squared. If you draw the parabola of g of x, we will have parabola that is concave downward or open downward, since the coefficient of x squared is negative. So my parabola is something like this, concave downward or open downward. And then this parabola will intersect y-axis at 4. If we want to find the y-intercept, then we can set x as 0. So this parabola will intersect y at 4 and then it will intersect x at plus minus 2. If we want to find the x-intercept, then y is equals to 0. You will get 2 minus x, 2 plus x. Then you will get 2 values of x, which is negative 2 and 2. So, if I imagine this as the parabola of g of x, then this point is negative 2 and this point is 2. And then the y-intercept is 4. This is 4. And then g of x, f of x is a parabola that is open upward, since the coefficient of x squared is positive. This parabola must intersect this parabola at 2 different points. So assume I have another parabola that is open upward or concave upward, and then my second parabola must intersect this parabola at 2 different points, and the y coordinate has to be positive. So I think our possibility is something like this or like this. As you can see, yeah, the y coordinate are both positive. Or like this, let's say both y coordinates of point of intersection are positive. it can be something like this. Because if it is like this, as you can see, one of the point of intersection is below x-axis, which is the value of y is negative. My point is, the point of intersection must be between -2 until 2, so that the y coordinates are positive. So the point of intersection must between -2 until 2, so that the value of y of the point of intersection are positive. So I think for m and n here, the answer is -2 until 2, as you can see from the illustration above. Okay, and then accordingly we have h of -m, m is 2, is equals to blah blah blah, must be greater than 0. This is the value of y, and then the value of y is positive. That's why we have greater than 0 here. H of x is f of x minus g of x. So my h of x is f of x minus g of x. F of x minus g of x. If you see f of x minus g of x, then this is the result. So this is my h of x. This is my h of x. And then I will substitute x as -2. I will x as -2. Then we will get -2 square becomes 4. 4 times 2 becomes 8. Minus 4a plus a square minus a minus 4. And then if you simplify it, you will get a square minus 5a, 8 minus 4 plus 4 must greater than 0, because the value of y must be positive. So I think my O is 5 and then P is 4. Same thing with h of n. N is 2. Just substitute 2 into this expression. Then you will get h2, 2 square 4, 4 times 2 is equals to 8, plus 2a times 2, which is 4a, plus a square minus a minus 4. Then if you simplify it, you will get a square plus 3a plus 4 greater than 0. Then Q is 3 and then R is 4. 3 and 4. And then also from the position of the axis of the parabola y equals to h of x, we have that blah blah blah. Axis of parabola means its symmetrical axis. My h of x is this. This is my h of x. The formula to calculate axis of symmetry is -b over 2a. This is the axis of symmetrical. So the axis of symmetry is x equals to -b over 2a. Remember that this is A, and then this is B, and then this is C. So this is A and this is B. So my axis of the parabola is negative B. B is 2A over 2 times A. Our A is 2. So the axis of symmetry is equals to negative A over 2. Negative A over 2. This is my axis of symmetry or axis of the parabola. Since the point of intersection of the two parabola is between negative 2 until 2, so the axis of symmetry of h of x must between negative 2 and 2. So negative a over 2 must be between negative 2 until 2. If I multiply all the sides by 2, I will get negative 4 less than negative a less than 4, and then times negative 1, we will get 4. Don't forget to flip the sign, negative 4. Then a must be between negative 4 until 4. This is our S and P. Then, therefore, from 1, 2, 3, and 4, we obtain the range of A. 1 is between negative 2 and 4. So, I will draw number line here. Negative 2 until 4. This is the solution for 1, negative 2 until 4, and then 2. What is 2? 2 is the solution of these inequalities. A square minus 5a plus 4 greater than 0. So I will find the solution of 2 here. We can factorize it. A minus 1, a minus 4 greater than 0. And then I got two critical values here, 1 and 4. And then I will draw the number line, 1 and 4. The coefficient of a square is positive, then the sign in the middle region is negative. Negative, positive, positive. And then I will take the positive region, which is a less than 1 and a greater than 4. So if I combine this number line into this number line, I will get 1 to the left and then 4 to the right. This is the solution of part 2. And then what is the solution of part 3? A square plus 3a plus 4 is greater than 0. 3a plus 4 greater than 0. If you see this expression or this quadratic expression, we can see that this quadratic expression cannot be factorized. If it cannot be factorized, that means I can check whether this inequality has no solution or the solution is x is a real number. How to know? I will find the discriminant. B square minus 4ac. If you calculate the discriminant, you will get 9 minus 16, which is negative 7. Since the discriminant is less than 0 and then the coefficient of a square, which is a, is greater than 1, that means this quadratic expression is definite positive. This is definite positive. If it is definite positive, that means this expression is always greater than 0. So no matter what is the value of a, you will get the result always greater than 0. So the solution for part 3 is a is a real number, since this is definite positive. You can check, yeah. Just put a equals to 2, let's say, you will get greater than 0. If you put a is equals to 0, it's still greater than 0. If you put a is equals to, let's say, -1, you still get greater than 0. So a is a real number for part 3. And then for part 4, a is between -4 until 4. -4 until 4. If you see from this number line, the region that is satisfied by 1, 2, of course 3 and 4 is this one. So this is my final region, which is satisfied 1, 2, 3 and 4. So a is between -2 and 1. -2 and 1 for U and V. Okay, this is the end of this video. Thank you guys for watching this video till the end. See you guys on my next video. Bye bye.